So we've talked about the identity matrix and we've talked about the determinant of a matrix. Now we're finally at the point where we can work out the inverse of a matrix, which is what we've been building towards. So the inverse of a 2 by 2 matrix, and this is important, again, like the determinant, you'll only ever have to know how to manually determine the inverse of a 2 by 2 matrix. If it's bigger, you'll be able to use your calculator. The rule here is that if we're trying to find the inverse of matrix A, that's just A, B, C, D, if that's our matrix that we're finding the inverse of, the inverse will be equal to 1 divided by the determinant of A. So you can see that it's going to be useful to calculate the determinant first. So 1 divided by the determinant goes in front as a scalar, as a number in front of our matrix. And then if you look at what's happened with the elements in the matrix here, you can see that the leading diagonals, A and D, have just switched places, right? So these two things swap, okay? The other elements, B and C, stay in the same place, but their sign changes. They become negative, right? So we get negative B instead of positive B and negative C instead of positive C. So the leading diagonals switch places. The other two elements stay where they are, but their sign changes, okay? And this is a really important note here. If the determinant is equal to 0, then the inverse matrix is undefined. And that's because if you've got 1 divided by 0 anywhere in a mathematical sum, you can't do it. It's not defined. It really is like it equals infinity, but infinity is not a number that you can define. So if the determinant of A is equal to 0, then the inverse of A is undefined or doesn't exist, okay? In your calculator, to find the inverse matrix, it's really simple actually. You just type the matrix in and then push to the power of -1. Right, so there's not even any menu buttons. You just type the matrix and then power of -1 and you'll get the inverse straight away. So that's pretty handy. Okay, let's go through example 4 here. And we're going to practice finding the inverse of this matrix by hand, but then we'll check our answer using our calculator. So the first thing to do when you're finding the inverse of a 2 by 2 matrix is actually to get the determinant. So I'm going to write that first. The determinant of C is equal to, for this one, it's 2 by 3 take away 2 by 4, right? Again, with or without the brackets, if it helps you can put them there. And we get 6 take away 8, which is -2. So the determinant of C is -2. And then we can say that, I'll leave that sort of separate, C inverse will equal, so remember it's using the formula, 1 over the determinant, so 1 over -2 times, and what happens inside our matrix is the leading diagonals, so the 2 and the 3 here, will switch places. So you want to fill those in first. The other two diagonals, 2 and 4, stay in the same position, but their sign changes. So +2 becomes -2, and +4 becomes -4. Right, now it is okay to leave your answer like that, okay, and it's completely acceptable, but it's also possible that we can write, so I'm going to say or, because I can write it either way, we can actually multiply that -1/2 into each of the elements. Remember, when you multiply by a scalar, you just multiply all the elements inside the matrix. So we could also make this -3 over 2, +2, because -1/2 times -4 would give us +2. -1/2 times -2 would give us +1, and -1/2 times +2 would actually give us -1. Right, now you can give your answer either way, but be mindful that when you're doing things like multiple choice questions, you might have to recognize that that answer is the same as that answer or vice versa. Okay, so it's important to understand both ways. Just quickly as well, we'll go through this one on the calculator just to show that it is quite straightforward. In fact, this matrix that we're doing here was the same one from the previous example, so I'm going to get super lazy. I'm just going to copy the matrix down and then put to the power of -1. And there's our inverse matrix. Now it looks, I'm in decimal mode here, so you can see that instead of getting 3 over 2, I've got 1.5, but it's the same matrix. All right, pushing on through these last couple, we've got example 5. Looks a little different. We're given a matrix E and it says to explain using an appropriate calculation why E inverse is undefined. Now remember that we said before that if the determinant is equal to 0, that's when the inverse matrix is undefined. So there's a good chance here that the reason this will be undefined is because we're going to get a determinant of 0. But if we're trying to explain that, we need to show the calculation. So we can say, let's work out the determinant of E, and it is -3 times 6, again, with or without brackets, so -3 times 6, take away -9 times 2. All right, now obviously at this point you can put that into your calculator, but if you want to do it manually, it's going to be -18 minus -18, which really equals -18 plus 18, which is 0. And therefore, the reason this is undefined is because the determinant of the matrix is 0, and that's what happens when the determinant of the matrix is 0. So we're going to say, therefore, E inverse is undefined as determinant of E equals 0. Okay, so we've explained using an appropriate calculation, and that calculation was to find the determinant. All right, lucky last here, this exam question. We've got a matrix A with the following elements, but one of them is missing. We've got this K, and it says that A is equal to the inverse of A for a particular value of K. Now, there's a couple of ways we could try to tackle this one, but what we're essentially being asked to do in this question is to try to get this matrix so that the inverse and the original will be the same thing. So, well, let's try if we were to think about this maybe without a calculator and try to work out what the inverse would look like. The inverse of A would be, remember, it's 1 over the determinant. Now the determinant of this matrix would be, actually I'll write this separately. Determinant of A would equal -3 times 3, so -9. Take away -4 times K. So take away -4K would actually be plus 4K. Okay, so we've got -9 plus 4K times, and remember what happens with the elements, we switch the places of these two, so -3, +3, and the signs change for these two, so we'd get +4 and -K. Right, now if we want this matrix, this whole thing here, to equal what we had when we started with, because that's the idea of the question, that A is equal to its inverse, well, you can kind of just look at all the elements here and see that what we really need is this determinant. The determinant here needs to equal -1, because if I were to multiply all these numbers by -1, I'm going to get back to what I started with. So we could say we want 1 over -9 plus 4K to equal -1. And my working might be a little bit hard to follow here. So this is the key idea. And we could try to solve that for K manually, but I reckon let's just chuck that into our calculator. And let's say we're going to do, let me see if I can get both of them in the screen there. Yep. So anytime you're trying to find an unknown that's sort of buried somewhere in an equation, go to solve. So we've got 1 over -9 plus, now you can go to the keyboard and use K. I'm just going to use X because the calculator, whoops, that's wrong. There we go. Calculator always tries to solve for X. So like I said, you can bring up K in the keyboard, but I'm just going to use X. And we get X equals 2. We're going to hope that's one of our options. Yes, it is. So we're going to be happy that the answer there is that K is equal to 2. All right, that's a pretty tricky exam question. So it might be worth actually looking at this exam question again after you've done the exercise on inverses, once you've had a bit of practice with it. But I hope that gives you an idea, a pretty long video I know, of finding the, or knowing what the identity matrix is, being able to find the determinant of a matrix, and also being able to find the inverse of the matrix. So have fun with exercise 12A and get in touch with your teachers if you need any help. Cheers, guys.